explain this. Yes. Hello everyone, this is Lakshmi. Welcome to my channel Lakshmi Lucky. Okay? Yeah, I'm explaining functions topic right now. In this important questions I'm discussing. So in this fifth theorem I'm explaining today. The statement has given here. Let f is a mapping from A tends to B has given. This is a function, and we need to show that here this function f is nothing but bijective function. Bijective means satisfies one to one and onto. Right now, yeah. And here one more condition. What is there? If and only if condition. If and only if condition means two cases will be arise. Okay. Case 1, case 2 we'll discuss in this. So in the first case, first condition we should choose then we need to prove f composite G is equal to IB as well as G composite F is equal to IA as well as G is equal to F inverse. Okay, by using this condition we'll prove these two cases. And in the second case you should consider second part. We'll prove given function is nothing but bijection. Okay, we'll prove and here G is a mapping from B tends to A has given, and for f composite G is equal to IB, if G composite F is equal to IA. We are proving these two cases by using G is equal to F inverse. Okay. Now given function is nothing but f is a mapping from A tends to B has given. This is a function, and in this first case I am taking f is nothing but bijection. If suppose if and only if condition is there, no, what I am saying, first case you should consider. Okay, we'll prove second case by using this function bijection. Okay, and if f is a bijection, then we need to prove that f composite G is nothing but IB and G composite F is equal to IA. Okay, and in this case G is nothing but what has given, G is equal to F inverse. Okay, anyway, since f is a mapping from A tends to B, we know that is the bijective function. Bijective means what I am saying, it should be satisfies one-to-one condition as well as onto condition. Is it right? Yeah. So its inverse function is nothing but also bijective function. That inverse function is nothing but defined as in the reverse case B tends to A. Domain is nothing but B. Codomain is nothing but will change A. So f inverse mapping from B tends to A. This is also bijection. Okay. And we know that f inverse composite F is equal to IA. Already yesterday we proved this theorem right now. And f inverse composite F is equal to IA from the identity functions. F composite F inverse is also IB. Okay. So in this case f inverse from the statement what has given G is equal to F inverse. Instead of F inverse, G you should take. Okay, so G composite F is equal to IA. Our required solution we should get. Okay, now taking G is equal to F inverse. Instead of F inverse I am taking G. So G composite F is equal to IA we should get and in the second case also F composite, instead of F inverse G you should write. So F composite G is equal to IB from this equation 1. Okay, second part we got now. If suppose f is bijection, we proved second condition. This is the first case. Okay. In the second case, converse part, we'll assume that it should be exist. What is the function G from B tends to A is there. Okay. And such that here G composite F is equal to IB and G composite F is equal to IA has given. In this case, G is equal to F inverse also is there. Okay. So by using this, we'll prove f is nothing but bijection. Bijection means satisfies one-to-one and onto. Right now, so we'll show here. We need to prove that f is nothing but bijection. G is equal to F inverse is there. Bijection, one-to-one condition. For one-to-one condition, suppose if A1 equal to A2, then f of A1 is equal to f of A2. We need to prove that condition. No. So let any two elements in the domain A. A1, A2 belongs to A. Then its image elements f of A1 and f of A2. Those two are elements in B. Okay. And because here f is nothing but obviously it is a function from A tends to B. Okay. And you should consider f of A1 is equal to f of A2 according to the definition of one-to-one. Okay, f of a1 is equal to f of a2. F of I'm taking on both sides function g. I'm taking on both sides function g. So g of f of a1 is equal to g of f of a2. So again this expression can be written as g of f of a1 can be written as, by using the composition function, g composite f of a1 is equal to g composite f of a2. Okay. Yes. So g composite f is equal to ia and g composite f composite g is equal to ib. We proved no ma. Yeah. So that means ia of a1 is equal to ia of a2. So here ia of a, from the definition of identity ma, ia of a1 is nothing but a1. ia of a2 is nothing but a2. So a1 equal to a2 means two distinct elements are equal to each other we got. So therefore what we can say here, f is one-to-one function. Is it clear? First condition is proved. Now we'll show second condition, f is onto. Okay, by the definition of onto ma, here let any one of the element in B you should take. Okay, and by the definition of onto, every element in codomain have a pre-image. Yes, no? So g of B is equal to a, where a is nothing but element in capital A only. That means the function is nothing but g from B tends to a is nothing but function is there. Right now? So f of a is nothing but equal to, now I am considering f of a is equal to f of, instead of a, from this condition g of B you should write. Okay, again by the composition function f of g of a, this expression can be written as ma f composite g of B. Okay, and f composite g of B can be written as ib, identity function, ib of B. That by the definition of identity, ib of B is nothing but simply we can take B. Okay, so therefore here f of a is nothing but what we got ma, B. So therefore we can say here f is also onto. So in this case the function f is nothing but satisfies one-to-one function as well as onto function. So then what we can say, that given function f is a mapping from A tends to B is bijective function. Right now? So this is the bijective function ma, and it is also nothing but obviously satisfies one-to-one condition, satisfy in the end, it should be exist invertible condition ma. So and we can say it is invertible function also. Okay, and that means f inverse is nothing but f is a mapping from A tends to B is there. Its inverse function f inverse from B tends to A. That is also invertible existed. I am saying no. So f inverse from B tends to A is also bijective function. Okay, and this means what ma? G and f inverse. G and f inverse. G is a mapping from what is there. Where is what is there ma? B tends to A. And f inverse also nothing but B tends to A. Here domain is nothing but same in both the functions. Right now f inverse and G both have the same domain, that is B. It is clear? And let B belongs to B, because we have to show that ma G is nothing but is equal to inverse function f. Both functions are equal to each other, we need to prove. So for that I am taking B is nothing but element in capital B. Okay, and since f is a mapping from A tends to B is onto, already bijective function we proved. So we can take this function is onto. Right now? Now by the definition of onto, what we can take ma? It should be exist any one of the element in capital A such that f of A is equal to B. That is the condition of onto. Right now? So here, and this function you should take on the right hand side, or you should apply on both sides the function f. Inverse function you should apply ma. So f inverse of B is nothing but equal to A we should get. So make this equation 2, 3. This is 2 and 3 ma. Now I am considering g of B. I am considering another function g from B tends to A is there na. G of B I am considering ma. Instead of B, here from equation 2, B is nothing but what is there? F of A. Right here g of, instead of B I am taking f of A since by the equation 2. Okay, And again, this total expression can be written as by using the definition of composition. Okay, G composite F of A we can write. Is it clear? And G composite F of A, simply what we can take? Identity function. So that is IA of A. By the definition of identity, again what we can take? Simply this element A. Is it okay? Now here it should be is equal to A means by using the equation 3. A is nothing but what is there here? F inverse of B. Right now? Instead of A, you should write F inverse of B. So therefore, here left side G of B is there. Right side we got F inverse of B. Here on both sides common element B is there. Gets cancelled. So therefore, what should we get? G is equal to F inverse. That only I wrote here. Okay. This is the required solution. It is also very important theorem in the functions. 5 theorems, main important theorems, should practice well. Okay. ఈ వీడియో కనుక మీకు నచ్చినట్లయితే లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేసుకుని వాళ్ళు సబ్స్క్రైబ్ చేసుకోండి. ఓకే.